Today we're going to be looking at segments, congruence, distance, and midpoint. Today's terms are a postulate or axiom. This is something assumed to be true for the basis of reasoning. Theorem, something that must be proven true. Coordinate, each of a group of numbers used to indicate the position of a point, line, or plane. Distance, the shortest length between two given points. And midpoint, the point that divides a distance into two congruent segments. Things to keep in mind: labeling differences between geometry terms. A line has a symbol with the arrows on both ends above it. This tells us that the line will keep going forever in both directions. Ray has the bar with one arrow over it, and the direction of this arrow will always be to the right. Whether the ray in the image is going up, down, left, right, however, you'll always name it starting with the end point and then a point on the ray, the direction it's going, with the bar with one arrow over the top. Segment has nothing on the ends of its symbol. This represents that it stops. It starts at A and stops at B, or it could start at B and stop at A. The direction does not matter for segment, and the direction does not matter for line. But with a ray, when you're naming it, you always have to begin with the end point. AB with nothing over the top, right here. That represents the length of the segment AB, or the distance from A to B, or the distance from B to A. If I ask you AB and then put an equal sign, that's me requesting the length of the segment. That's what you could see over here. AB equals blank. This is looking for a number as the answer. I'm asking for the length of the segment or the distance from A to B. There are some formalities in naming that we need to keep track of. Segments can have their proper name, which has the bar over the top. If you are using the name of the segment, the symbol in between will need to be the congruence symbol. This states that segment AB is congruent to segment DC. Now, very similar to that, we have down here AB equals DC. This represents the numeric measurement of the segments. So they're very, very similar. It's just really a technicality. If the segments are congruent, they do have the same length. And we're going to be going between these symbols as we do proofs. So you need to just kind of know that the equals is representing a numeric measurement, and the congruency is representing the formal names. So it seems silly now, but we are going to go back and forth between these two and the symbolic way of writing them. So be careful, watch carefully when you are seeing that. Congruence markings. If you have congruent segments, they'll be marked with a tick mark, which is like here and here. You could have a double tick mark, which is what we've got going on over here for those two congruent segments. And to write the congruent statement that goes with those segments, we've got that down here. You have the bar over it, so segment AB congruent to segment BC. And on this segment here, it's congruency statement there. To label congruent angles, you're going to use arc markings. So a little curve. Here we've got a single, and we've got the angle congruency statement there, naming the angles with the congruent symbol in the middle. Notice that it's angle A, which represents the name, congruent to angle C, If we wanted to write out the numeric measurement, we would say the measure of angle A is equal to the measure of angle C. That would tell me the numeric measurement is what I am talking about. So just kind of a technicality to watch out for. Over here you can also see we sometimes call angles by numbers. Angle 1 congruent to angle 2, and they have the double arc markings. Sometimes you could see an arc marking that has like a little line in the middle just to make a different marking. Just depends on how many markings you already have in the diagram for wanting to make those changes. The ruler postulate. This states that the distance between 2 points on a number line is the absolute value of the difference of the coordinates of the two numbers. So for example, we have a statement here, this is the rule. AB equals absolute value of A minus B, and it also equals absolute value of B minus A. Here's an example question. It says find AB. So we want the length of AB as a number if A is at negative 33 and B is at 15. So we're looking for the distance between these 2 points. So that ruler postulate states that we could do the absolute value of the difference. So we could do the absolute value of negative 33 minus 15, or the absolute value of 15 minus negative 33. So whichever one we want to do is fine. And you would just simplify that. So remember that the absolute value means whatever you get when you simplify, you just take the positive value of that. Absolute value represents distance from 0. So it's always a positive when you do the absolute value. So I'm going to look at the 15 minus negative 33 to do some mental math here. Minus and minus means we're going to be adding. And so that is going to give me 48. So the length of AB is equal to 48. Here is another example, but on this one, rather than wanting the full length, we are wanting to talk about fractional distance. This means we're going to go part of the way between one to another along the number line here. So we've got A, which is at negative 10, and we've got B that's at 15, and it says what number is 3/5 of the way from A to B. So we need to know we're going to start at A and go towards B 3/5. So I have to think about what that amount is. So the first step in this, I'm going to decide how far apart they are. So negative 10 there, and positive 15. I could do the ruler postulate, taking the absolute value of the difference, or I like to look at, if it's already on a number line, I've got negative 10, so negative 10 to 0 is a length of 10. And 0 to 15 is a length of 15. So we've got 10 and we've got 15, and so the total distance is 25. We want to go 3/5 of that distance. So we want to figure out what 3/5 of 25 is. So if 1/5 of 25 would be 5, 3 of them would be 15. Now, the most common mistake that gets made is people to say that the answer to this question is 15. Well, 15 is the distance we need to go, but it's not the answer. The answer is what location we end up at when we start at A and go 3/5 of the distance. So we need to go 15 from point A. So we're going to go back to A, we're going to go 15. Their markings are 5, so 5, 10, 15. Will put me right here. The coordinate, that is 3/5 of the distance from A to B, is going to be 5. So the answer is 5. So make sure you are completing the question by going back to the number line and going the distance they wanted you to go. Also, double check that you go from the correct point. So this question, I was just rereading it. I noticed that there's actually two questions. So the first part says, what number is 3/5 of the way from A to B? That's 5. The second part says, what about 3/5 from B to A? Well, if we're having to go from B to A, 3/5, we're going the other way. 1, 2, 3. That's going to put me at 0. So the second question, the answer is 0 for 3/5 from B to A. So always make sure you're answering all the questions that they're asking. Always reread the question before you decide if you're done. I can't tell you the number of times that I didn't finish the whole problem. So always check for that. Segment addition postulate. We are going to be using this when we do proofs later on in the course, and it is a very, very important rule that you will need to know. The segment addition postulate states if B is between A and C on a line segment, then AB plus BC equals AC. So, very important. And it seems really, it's like common sense. If you notice, anytime it says postulate, most of those are going to be things that feel like common knowledge. Like if you look at the picture, they make sense. So it seems like they didn't need to tell you that, but we're going to have a lot of those. So notice how AC, segment AC, that's the whole segment. Well, it's made of two parts. It is made of AB and BC. So we're able to know that AB plus BC will give us AC. Remember that with no symbols over the top, when it's just the letters with no bars or anything, that represents the numeric measurement of that line segment. So the length of AB, when added to the length of BC, will give us the length of the segment that they create together. We're going to use this in proofs whenever we want to take a segment apart and talk about its pieces, or if we need to take two pieces and put them together. And it's going to be really important for those. At this time, we're going to use the rule to do some mathematics to solve for missing lengths. So here's a sample question. Assume point C is between A and B on segment AB. So we don't have a picture. I'm going to draw a picture. So I've got segment AB, and it says C is between them. So I need to state that between does not mean very center. So I'll always put this just sort of off center, somewhere between. It says that AB is 50. And CB is 15. And it says, what's AC? So in order to do this question, we'll just be subtracting 50 minus 15. So that's going to give me 35. There was no algebra involved in that one, so pretty easy to do. The next one is using the same idea, so I'm going to draw a picture for that one. It's using the same instructions, A, B, C is between. If AC is 2A plus 3, and CB is 3A minus 1, and they said that AB, we didn't give y'all very much room to write here, sorry about that, AB is 37. So this one, we have algebraic expressions, and so we're going to be adding the pieces equal to the total. So that means we're going to do our two expressions, 2a plus 3 plus 3a minus 1 equals 37. In order to solve an algebra equation, you're going to want to look for things you can simplify, such as like terms on the same side. I have like terms 2a and 3a, so that'll make 5a. I also have like terms of a positive 3 and a negative 1, which will combine to be a positive 2. So 5a plus 2 is 37. And then to solve for a, we're going to isolate our variable first by, if they are adding or subtracting anything there, we're going to get rid of that part before we do our dividing or multiplying step. So I'm going to subtract 2, giving me 5a is 35. Divide by 5, a is 7. So the value of a is 7. Now you have to make sure, what did they ask you to do for the problem? So for this problem, they want a, so a is 7. They want ac, so we're going to have to plug in the 7. So that would be 2 times 7 plus 3. That's going to give me 17 for the length of AC there. For the length of AB, well, that was actually given to us in the problem, 37. And CB is going to be 3 times 7 minus 1. So that's going to be 20. So my picture was not to scale. CB was longer than AC, but that's okay. So we use the segment addition to add the pieces equal to the total segment there and solve for a variable and plug it in if they want us to find the pieces. This is using the segment addition postulate, but it's more of like a brain teaser. There's more going on. You're using segment addition a lot of times. We're also using congruent markings and given information. So they said in the instructions that B is the midpoint of AE. Well, if B is the midpoint of AE, that is the point in the very center of segment AE. That means from A to B is the same as B to E. And since there's a lot of other dots in here, I don't have a good way to mark it, so I'm just going to use these squiggly brackets to kind of notate that. They want to find the lengths of the segments below. They've also labeled some congruent segments, and they've labeled the length of BC. Well, if BC is 6, and we have these congruent markings, the congruent markings are telling us that everywhere you see that marking is the length of 6. What that means is now we are able to see that from B to E would be 3 of these segments, making it a length of 18. And if BE is 18, so is AB. So we can go from there, finding our missing pieces. DE is 6, AB is 18, and AC, well, AC would be made of AB plus BC, therefore segment addition postulate tells us we can add those two together. So 18 plus 6 would give me 24. So that is using segments and the ruler postulate and segment addition postulate. I'm going to do a separate video for the distance and midpoint formulas.